Kyle?
Yeah.
You're live now. So Kyle is now going to take us through the second part of today's session. We start now.
Yeah.
Right?
Yeah. We'll start, but I think we should do the setup first. So make sure that you can run the notebooks along with us. Has everyone completed the setup, or is anyone stuck?
I am horribly stuck with this. I don't know how to uninstall fast. I don't know why I added fast HTML. And after I got fast HTML, good.
In your case, let's take it offline. As soon as the session is
I'll do that. Yeah.
Yeah. So you'll all set with you and take it from us.
Okay.
Anyone else needs help, guys, before we make progress? Anybody who got the environment successfully set up, please give a thumbs up or some sign that you are there. Any successes so far in getting the environment? There's a lot of silence. Anybody who would like to have some more time to continue? All right, Kyle, I suppose at this moment, let's continue. There's a lot of people and we can help them synchronously as they ask for it. Discord, so please continue.
Sure. Okay. So yes. So the second second lesson we'll be going over is the introduction to pandas. So we just saw that how NumPy was a fantastic tool for numerical computations. But now a data set won't just comprise of numbers. We will have many different types of data as well. So in Python, to work with tabular data, we use data frames, and Pandas allows us to use, Pandas gives us the capability to work with tabular data. So we can, so we'll just quickly go over a short introduction. So Pandas is basically panel data, and it was born out of the necessity to work with tabular data in Python. It is very similar to, it works similar to SQL databases and Excel spreadsheets. So with Pandas, you can load your data from different sources into Python, clean the data, analyze and visualize, and you can do much more. So the standard way of importing Pandas into Python is import Pandas as PD. Just as we saw for NumPy NP, we use PD. Now, with Pandas, it is a columnar data storage. So we have, you can think of Pandas data frames as a dictionary of columns. You have a key and a column, a list of values, and each value in the list is of the same data type. If you want to compare it with an Excel spreadsheet, it would be each row would be an index, and each column is a column here as well. So a row you call in pandas, it is called an index. Right. So now you can load a data set. There are multiple ways to load a data set, and this will come in handy when we're working with different data sources. And it's very easy. You can check the different ways to load from the pandas documentation. Here, one of the standard ways, the standard things you'd be doing is loading it from a URL, and generally you'd be loading a CSV file. In that case, it's just pd.read CSV, which is a very easy to remember function. So once you load a data set into a data frame, the first thing you would want to know is what is the shape of my data. Just as we had the property shape for a NumPy array, we have the same for a data frame as well. You can check the shape of your data, and that would be that would tell us the number of rows and number of columns in your data frame. So once you have seen the shape, the next would be generally it would be that your data sets would be huge. You'd have thousands, 2,000, and a huge number of records. In that case, the what you would like to do is just see a few rows, take a glimpse of your data set, and you could do that by using head or tail. You can check the head and tail of your data set. So in this case, the data set that we have loaded has 4 columns: station, date, Tmax, and Tmin. So Tmax here refers to the maximum temperature of that day, and Tmin is the minimum temperature. And we have the date as well. So we can see that it is not really that well formatted right now. So we would like through this course, we'll get to reformat this data. We see that date is like a number here, and we would probably want it in a different format so that we can do some processing, or we can get some insights from this table. So this is the data set that we have. Now, the first thing is we would like to see what is the type of each column, right? Like what is the data type of each column. Now, to do that, we can simply say df.dtypes, and we'll get, for each column, we'll get the data type. So what we get here is a series object. So in return, in pandas, there are these two basic like structures. One is the data frame, which is a 2-dimensional, which is a table, and then we have a series, which is a column. So whenever you get a single column, it's usually of a series type. So you have a key and a value. Then once you've seen the different data types that you have, you may want to change the data type for a specific column. So to do that, we have toDateTime function, and you can use that to change the format of your date. So these formats are all specified in the documentation. You can check them, but you have the option to do it. So here you can specify that you want it in this particular format, and you want to process it as a date instead of a number. So if you use this, you'd get the date column formatted as a date time. The next thing is we saw that the station is of type object. So this is a very generic, a generic data type. generally you would prefer to have strings as specifically you would like to cast it as a string instead of just keeping it as an object. So that for that case, you can say as type. You can convert a data, a column of any data type to the one that you want using as type, right? So then you can describe your data set. So like we have it would be good to summarize some of the variables that summarize the data set that you have, and the summarization can be done using df.describe. And the way you if you do just df.describe, it will describe all the numerical variables in your data frame. Numerical variables are those variables that have simply just numerical values. So in our case, we had 4 columns, and date is also considered a numerical column, tmax and tmin. And here we have some information about it. What is the mean? What is the minimum value? What is the 25th percentile? 50th? What is the median? What is the max, and what is the standard deviation? So for some cases, it is not, for date specifically, it is not applicable. So you'd get, wherever it is not applicable, you will get a nan value. Now, if you would also want to include the categorical value variables in your description or your summary, you use include all. So this would include all the string and object type data types as well. So for categorical variables or string, you would mean, median doesn't make sense. So you'll get some additional parameters to describe, which is unique. What is the top? What is the most frequent? And what is the frequency of that of the most frequent? So this is the describe function. Then you can change, you can set an index. So an index, as you see, identifies each row. And so you can set in this particular data set, it makes sense to have the index as your date, because the measurements are done per day. So and you would want to identify each row by the date on which it was measured. So in that case, you can set an index for your table, for your data frame, and you can do that by saying df.set and date. So you specify the name of the column. So then once you have set the date, you can take a look at the data set. But now you see that whatever changes we have made are not reflected here. So that brings us to another key like property of data frames, is that whatever modification you do, it will not get done in place. Like the data frame is not modified by itself unless you specify it explicitly. You could say set index and specify in place, right? And then set that value to true. Then the change would happen in place. But if you do not set it, then it will not happen. So another way to do this is say df equals to df.setIndex, or whichever modification you do, you assign that modification to a new variable, right? So this way you would try the changes you made would reflect. So yeah, so here so you have to you have to make sure that the modification is recorded. So once that is done, we can do some exploratory data analysis. So what we've done so far is imported the data. We have just glimpsed the data. We have done some very basic statistics on it. And then we have also modified some data types, modified the index and all of that. So now we have our data in say a good shape to visualize it. So to visualize the standard library in Python is matplotlib. You would be installing it with the requirements, so it will come installed. And if you notice, we haven't imported any other libraries and we are just using them. That's because we have a notebook called support vectors common, where we import all the necessary libraries for this project, for this course. So it has a lot of libraries that we import. So here we have already imported matplotlib, and an easy, very simplistic way that pandas, just like in NumPy, we could plot the data. You can just like matplotlib is also integrated with pandas, so you can just say give a specific column and say dot plot, and this would create a nice line plot for us, showing how the maximum temperature varies across the month of January, right? So we get some insight, and we do see that we have the first few days, the temperature was pretty, low. So then you can also plot multiple columns together, and by passing in a data frame. So if you see, the way we select a column is by using the square brackets. And if you want to select multiple columns, that becomes a data frame. When you select a single column, it's a series. If you have multiple columns, then it's a data frame. So then in that case, you pass in a list of column names. And if you don't provide this list, you'll get an error message. So you always pass a list of columns when you want to convert when you want to select a data frame. So so with that, we see that we have plotted two columns together, and then we can also do a histogram plot. So plot gives you a line plot, and hist gives you a histogram. And you can specify some additional like parameters, like the number of bins that you want, and you get some customization, like formatting options as well. So so this becomes very easy instead of importing another library and working with it. So you have df, tmax, and hist, and you get a histogram. You can also plot the same density plot, but using kernel density plots, which makes it a little bit smoother. And so we have options to modify that to some parameters. So you have df tmax plot. So once you are done with the plotting, and once you're done with your analysis, you may want to export your data into, let's say, a database. So oops, sorry for the typo. And here for this course, there is a database, a SQLite database that comes with your notebooks. So this database, I'll open it and show it to you later. It has a few tables that you can import and play with, and so you get a practice of importing and exporting to a database. So here I've connected to that database using SQLite, and using a connection, I have exported the table to the database. And it's a very simple function, and you just say df.toSQL, and specify the name of the table that you want to write, the connection, and then this is just to make sure that you are writing to it, even if it exists, right? So, and once you do that, your table is in your database now. You can also, strange. So you can also, once it's in your database, you can query and you can write, if you're very familiar with SQL, it would be, you can do all the transformations directly, say do a select or select with some filters using a where clause. So you can do all of that and just write a query, put that query in read SQL, and you'll get your data frame back. So here I'm selecting all the columns and selecting the entire table, but you can do some filtering and then bring it back into pandas. So this has been the introduction to pandas. So we have learned the different terminologies associated with the data frame, which are index and columns. Then we have loaded a data set, inspected it, visualized it, and exported it into a database. So in this lab, we have seen data sets that are actually, you would call these data sets tidy data because of the format. We'll see, generally data sets, not necessarily they would be like this unless they are, from a well-known repository and standard, data sets. So there, we'll have to clean the data set to bring it to this level. And for that, we will see some techniques in the upcoming lessons. So any questions?
Well, there is one question in the chat. Do I need to replace a folder path to my env to set up the environment?
Folder path in the README file. There is actually what you need to do is you have to cd into this change directory into this particular root folder before you proceed. And then you can just run this commands, like as an pip install -r requirements should work.
Yeah, alternatively, once you have loaded it in Visual Studio, as Kyle pointed out, you could go to that terminal menu right at the top and it will automatically take you into the directory. But remember to go into the activate the environment you created.
No, I think the confusion is whoever is asking this question is asking whether my_env is a folder. No, it is just any name that you would like. The my_env is not a folder. It is just any name that you would like to keep for the virtual environment.
Yeah, it's just a favorite name. People give colorful names. They can give the name of the cat, Felix. So conda create minus and Felix, my cat. Just something memorable, so you can later on activate that environment.
How do you open the database.db?
How do you open database.db? You don't need to.
Right.
As in the Jupyter notebook, she'll say, Kyle, would you like to take this question?
Yes. So there are some tables. Actually, in my case, what I have done is I have a DB viewer, so I can view the tables. But if you can import the table into your, let's say you don't have access to the database. So if you want to import the table into your database, you can, this is the way to do it. Import the table into your into a Python environment. This is the way to do it.
Okay, 1 second. See, you see that SQLite 3.connect, and you give it the file name, the database file name. SQLite, it just keeps data in a file. Because you give the file name, two things will happen. Either that file exists, so it will open the database, or the file doesn't exist, then it will create a new database in that file.
Yes. What is SQLite here?
SQLite is the simplest database, in-memory database you can build. Think of it as the tiny version of Oracle, the tiniest version.
So what do we contend that the database.db is just file name?
Just file name. We can call it anything. You can, for example, you can call it Dhamu.db.
Okay. Dhamu.
Any other questions?
So, during the installation, I was able to install except for one package, it said that Pydantic 2. I gave 3.11, installed in 3.11.9 Python version, and it was looking for Pydantic 2.0, but it has 2.8.2. Still, it installed.
It's okay.
It's okay.
That is all right. So, guys, if you see any issue with the Pydantic warnings, let those warnings be there. For the duration of this course, we won't be using Pydantic much. It just happens to be a library we use for projects that will come downstream when you take the other courses.
Right. So we'll go over lesson 3 and 4. And once we are done, there's a short lab. It's a solution. So we just have a short lab and we have in the end, this would be our goal. So we'll quickly finish this and we'll go over to the lab so that you can practice importing tables from the database and doing some sort of analysis on it and like answering a few questions from the using Python, right? So using pandas, we'll try to answer some questions. So the next lesson is on dealing with rows and columns in PANDAS DataFrame. So we saw how we can select a single row and a column, but you can do much more with the rows and columns. So in this case, let's say we have a simple data frame. I mean, you can convert a dictionary into a data frame. So that's what we're showing here. As you, in the previous lesson, we imported the data frame from a CSV file.
Sorry, so quick suggestion. Can you make the font a little better, bigger?
Yeah, sure.
Or perhaps go in reverse video, probably. This is good. Thank you.
This is good. Okay. Yeah. So we have a dictionary here, and when you have a dictionary with keys and a list of values, the pandas data frame, and you pass in the dictionary, the columns the column headers become the keys, and then the keys become the column headers, and then you have the list that becomes the column itself. So we can convert the dictionary into data frame, and when you print it out, this is how it would look. And here we're just describing it as we did in the previous lesson. And yes, so this is how you would select a specific column, and this is how you would select multiple columns. Let's say, okay, let me run this notebook. Yep. Right. You could also now you've selected all the values. Now if I say I want to select the record where the name is Peter, right? So how you would do that is you would have data where this column value equals Peter, right? So this would give me the row where the value is Peter. Now I can add multiple filters to this. So this is one specific filter. Let's say this is a filter. and I call it Peter, right? Or Peter filter. And I can also add another filter. But okay, since this is just a single row, I can do another type of filter where age, let's say age filter, where age is less than 25. And I pass in the age filter. Right, so you get this. So you can keep adding multiple filters by you can add it with an and. So this would make sure that both the filters are applied and only the rows that satisfy both filters, are selected. Or you can use or using the pipe symbol, right? So this is the filtering concept. So you can select multiple columns using the column name, and by giving the list of the columns, you can also
essentially it's a select command, like SQL select.
Yeah, exactly. Yes. Right. So then you can also select the columns using its index. This is not something you generally do, but in case you want to select the first three columns, you could do it this way also. Then you could also subset the rows and columns using location. So this is where you use the index, and this index so if you have so when you're using location, there are two parts to the location. One, like the first is the rows and second is the columns. So anything that comes before the comma is what you specify for the rows, and anything after is for the columns. So if you see 1:3, does anyone know? I mean, in Python this is common. So could anyone answer what this means, or take a guess? This may look a little cryptic.
Does it print columns 1 to 3?
Yes. So it just prints columns 1 to 3. And this is a list of column names. Sorry, this prints rows 1 to 3. So anything before the comma is the specification for the rows. So it prints the rows 1 to 3, and it prints these two columns.
So it's like a view, a smaller view on a database
Yeah.
table. Yes.
Yeah. So then you could also use the same colon symbol to select columns that are from name to height, which would include age as well. So then these are just some ways to select your table. I mean, select views from your table. Then selecting based on data type. Again, this is not something you do generally, but just showing you that it's possible. Now you use index location. So this is while in this previous case, we were using the names of the columns for location. For index location, you purely just specify the order of the columns, or order of the rows and columns. So this is another way of slicing your data. Then you can use for deleting rows or columns. In pandas, it is drop. So you could say you want to drop this column by specifying drop, or you can even say drop and you can put in columns. Okay, and then you won't need to specify axis. So an axis actually specifies an axis 0 refers to rows and axis 1 refers to columns. So then you can also rename your columns, data.rename columns, and you can specify it as a dictionary where you specify the old name as key and then the value within of the new name. Right, so and then here printing it out. You can add more columns to your data frame. Let's say you want to add an address, right? And you have all the 4 values for the table. You can just say data address equal to address. So here you add, this would just simply add a new column to your data frame. Now the next is row operations. So like we saw in the introduction, you can set an index for your table, right? And once you set your index, why would you set an index? You could use this easily. You can locate using the value of this index. So then getting rows based on a condition. So we just saw that earlier. So this is how you would filter your data frame. So this is a specific filter, and when you just apply this filter alone, you will get true or false. Just like in NumPy, you would get a list of booleans, and in this case, it's a series. And now when you apply that series to, let's say, this data frame, you will get the values that, pass the condition. And you could also reset your index. So you set it, now you can reset it using reset index. Now we saw ways to add a additional column. Now, how do you add rows? Let's say you have a specific table. You can add a row by adding a record. So this way of specifying a data frame, adding a row is by specifying a dictionary where for each column you have one value, and then you simply concatenate that row. So concatenate concatenate is to combine multiple data frames together. So they would you can concatenate on any particular axis that you want. So in this case, we are concatenating along the row axis. So you can do it on the column axis as well, but that you would generally not do. So then you can delete a row. So using delete a row, and in this case, you can, if your index is name, you can say drop Peter, and by default drops rows unless you specify the axis as 1 or you specify columns. So in this case, if you say drop and you given a certain name, so this would drop that particular row. So this is the end of lesson 3. Any questions?
So how does it knows that it has to drop from the name?
So you're setting the index,
Okay.
right? So once you set the index, the table's index becomes the names, and then you say drop, and you pass in a list of index values that you wanted to drop.
Okay.
And by default, drops along the drops rows. And you can make it drop columns by specifying, let's say, data.
Or an axis, probably.
Yeah, or an axis. And this would be, you can pass in a list of columns here.
So if I say the list of column, then it will drop all the columns basically, right? All the rows in
Yes.
that column.
Yeah, all the rows in the column.
So like once you drop that, then you can bring back.
Bring back, you'll have to add it back. Add a new row like we just saw earlier.
Is it
using
something?
concat.
So if my understanding is correct, usually you don't do it in place. You always do the new data frame. Data frames are very cheap to store. So it's easy for storing the new data frame with the drop. So right now it's in place, so you cannot do it. It's a no revert operation.
Yes, actually, generally you wouldn't need to delete. You can just create a new data frame with the columns that you want, say df, and then specify the columns that you want, right? So that way you can refine, or you can do a filtering. You can create a new data frame and say you can apply a filter to the existing data frame by removing certain names, like, where in SQL you'd say where this is not equal to Peter. So you could specify filters, and you can reassign a new data frame with a new set of columns, and removing the columns that you don't want. So both that, I think, would be the ideal and way to do it. But yes, in case you really want to drop, this is how you drop. Right? So okay, so we can go to the fourth lesson. So here we'll actually work with the Grand Slams winner data set, which I just created. So this, because I like tennis. So I created this data set, and it has the winners of Grand Slams from the year 2000 to year 2024. And let me show you the table. Okay, let me just, in case you want to view the tables. Right, so we have a few tables here, and we have 4 tables: one Australian Open, French Open, US Open, and Wimbledon. And so what we want to do in this lesson is we want to sort of combine these 4 tables into one. We do see that all tables have, fortunately, they have the same column names. They are actually in a tidy format. So it's very easy for us. So let's combine these 4 tables into one in pandas. And let's say we have 2 tables here and 2 as CSV file, and one in a URL. So that's where pandas comes in. You can just load them all into your pandas data frames and then combine them together. So here, however, to make it simple for us, all of them are as separate tables in this database. Right, so we will connect to the database, and let's load the tables into a dictionary. So we're going to have 4 keys, one for each table, and in that dictionary the value would be a data frame. So we're going to have a dictionary of 4 data frames. So, so we're just adding, so we are reading from the SQL, reading from the database, selecting all the values from the table, and using our database connection. So now we will have 4 tables, 4 data frames, and we have Wimbledon. It has 24 rows. We have Australian Open 25, US and French Open, right? So, right. So now, in this lesson, there are 2 types of adding, combining these. Combining these data frames. So the first one is concatenation. So in our case, let's say we want to just simply concatenate these 4 tables and make them into one long data frame. How would you do it? We just saw it in the previous lesson also. So we first convert them into a list, right? So we have a list of data frames and just say pd.concat. And since they all have the same column names, this becomes easier. Otherwise it could be a little messy. So in our case, it works out well because all the column names are the same. So we just say Grand Slams DF and we concatenated them. So now we can see that the shape, it has like 98 rows and 4 columns. Let's just take a sample. And we have the 2011 tournament, French Open, where Rafael Nadal was the winner. Then we have, we can just see, let's just view like 50 rows just to see how it looks. Now we can see that we start from 0, the index starts from 0, and it goes back to 0 again. So that's how it was in the original table. So this is something that we would not want. We would want the index to uniquely identify each row. So for that, let's reset the index, right? So once we reset the index, each row becomes unique. Now,
for Kyle, would you have repetition, like the year would be repeated again, or?
Yeah.
Okay.
Definitely. It doesn't matter that the year gets repeated because in a year there would be multiple Grand Slam tournaments,
yes.
right? Yeah.
But you don't want the tournament to be a list. Let's just say Jack Sinner won Australian as well as the Wimbledon for 2024. You don't want the year to be unique. You're okay with the year to be duplicated.
Yes.
Okay.
That is okay.
Okay.
So what will be the index over here?
Index is just integers. Okay. Let's say this integers, this is like the primary key, and we just have like numeric ID for each row, because anything else wouldn't make sense as the primary key. There could be
year could be, but then in that case you get
the table would be different.
Multiple,
yes.
yeah. The table would look different. Correct.
Yeah.
The rest of the columns would would have lists in it.
Yes, that would be the case. Or you could have a column for 2024, or you could reorganize this table differently. But this structure of a table again is called tidy data. And this is what you would prefer. You could have it as list, but it would make it very inconvenient for doing any analysis on it. Right? You could have 2024 and have all the winners of 2024 in one list, but then how would you do filtering, and everything becomes more complicated. So this would be the most simplest way of displaying data, of putting it in a data frame. right? So now we've reset the index and we're just viewing and making sure that we have a unique index for each. Now, if you see the old index does not get removed, but you can specify it, like you can make sure you can specify drop and it will drop the old index. So that is also possible. Now, there is column concatenation. We just saw in the previous one, but this in this case it doesn't make sense, just showing that it is possible. Now we have repeated column names. You would generally not do it if you want to combine two tables, laterally. You would be performing the best way is to perform a join like in SQL, and so we'll see how to do that in Pandas next. So in also another way to make sure that you don't mess up your column names and you don't have multiple, columns with the same name, you can use verify integrity. This applies for along both axes. Let me run this from the top. So okay, so it says run. Let's say I want to do this concatenation, and if I just do it like this, Pandas will do it for you. But ideally, you want to make sure that you don't. Let's say you have repeating column names. In this case, all of them are repeating. But let's say you have two data frames and just one column is repeating and you did not notice it. You should use verify integrity always whenever you're doing concatenation, and it will make sure that your column names aren't getting repeated. So in this case, if you try to do it, it will throw a value error saying you have these repeated column names, right? So this would protect you from making mistakes. Then let's say in our table, we didn't have, we saw that this particular column actually makes no sense here, because let's say Wimbledon, we know it's Wimbledon, and let's say this particular column was not present, and for in all these tables, and if we do a join, we would not know which record belongs to which tournament, right? So let's say we have that case. So what I'm doing here is, this is where I'm doing the drop. I'm making sure that in my table, I mean in my data frames, I don't have that column tournament. And if I do it that way, then this would be my, let's say Wimbledon table would look like this. So now if we try to, join all these, concatenate all these data frames together, it will, and without the tournament name, it would be very difficult. So we need the tournament information also. So for that, you can add an index, say Australian Open. You can add indexes while you do the concatenation. So here, if you see, I'm passing in the data frames. So dot values will get me all the values in my dictionary. And when I pass in the keys, this would create an index where this is multi-level indexing. So we have the first index, which is like numbers, and then we have another index which tells me which table these records came from. So then I can simply use dot location like we saw previously. Dot location helps you get, select based on index. So we saw in the previous example of Peter, you selected all the records having index Peter. So here you can select Australian Open. So we get this table.
So,
right?
so the intuition there, Kyle, is that when you concatenate, you have an opportunity to add some extra piece of information, like an index, that can come from that particular unique table.
Yes, correct. You can add some more information that you can use to identify each record. Yes. So then the next, so we've seen concatenation. So this makes sense when you want to add rows, like when you want to combine into a single table and concatenate by row. But for columns, merge would be the ideal method. So just like in SQL, you have the inner, outer, left, and right. Um, so inner would make sure that if you have two data frames, only the common elements are selected, common records are selected. Outer would include both data frames completely. And whichever, let's say, you have, we'll see how this would look. Then we'll have left, and this is the right join. So here we are taking another smaller data set where we have tennis players and tennis winners. Okay, so we are seeing, so we see the players. This data frame has the player and their country of origin. And here we have the player and the year they won Wimbledon, right? So we see in 2020, we didn't have a tournament of Wimbledon happening because due to COVID. So we get an and there. So these are the two tables. Now, if we want to join these two tables, right? And and we want year, player, and their country of origin. This is how you would do it. In SQL, you would say join, and you would give an on, right? So it's very similar. The syntax is very similar. You just say pd.merge, specify the two data frames, and on which column you want to join. Let's say that you know these two tables don't have the same name. You can say right on, left on. And let's say this is like player, and this is something else like Wimbledon winner. So then you can join that way. You use right on, left on. Also, you can do an outer join. And when you do an outer join, we see that some players have not won any tournament. So won any Wimbledon, so you'll get an an. And some tournaments didn't take place. Like yeah, in 2020, we don't have any tournament taking place, so it's nan. So we get an outer join. Then left would include make sure that all the players are there, and right would make sure that all the tournaments are there. So in pandas you also have join, but it is slightly different, and generally you wouldn't use it. So it just is a slight syntax variation. You have data frame.join. So df.join, and you have to have an other data frame. So df.join other, and you have to specify an index for the other data frame. So all this is not required when you're using merge, and you can just specify an on key. But here you have to make sure that the other data frame has this index set. So generally you would not use join, but here, so here we are showing an example of how you could use join. Also, the another important thing is when you're merging, you would want to validate. So if you see you see these squiggly lines, like Sonalint is catching it, saying you're not validating. That's why we're getting this warning. So so whenever you're doing a merge, you should make sure that you are validating, and you at least know which style of which type of merge you're doing. So let's say, is it a one-to-one, or is it a many-to-one or many-to-many? So one-to-many, I think it's so when you're doing a merge, making sure that each record from table 1 and table 2, they match 1-to-1, is the mapping from the first data frame to second data frame 1-to-many, or many-to-one, or many-to-many. We should specify it. So in this case, what type of merge are we performing? This player to tournament. What type of merge would this be? Is anyone responding? Hello? Oops, let me run this.
What happened, Kyle?
No, I just asked a question.
Okay.
So
I think people are getting tired now, so we can
okay,
stop
sure.
after this.
Sure. Yep. So that's it. We are done with the 4th lesson as well.
Sorry, Kyle, what
So-
was the question you asked? Sorry. What kind of a join would that be?
Yeah.
Okay. Inner join. Okay. So that's an intersection set, isn't it?
Yeah. I mean, we are doing an inner, and we are so it's 1-to-many, right? So we have one
okay,
player.
1-to-many. Okay.
One player. There's one player, but there are many tournaments that they could win. So it's a 1-to-many join. So yeah.
I have a question.
Yeah.
If I could, sorry. So when you're performing this join, I noticed the year, the data type of it is changing into a float. Some of the entries were saying
Right.
2010.0.
Yes.
Is that something which we can avoid, or like how does it treat the info?
Let's
like does it automatically detect that it is an integer and then does the formatting or something like that?
Yeah, it is implicit, but you can, if you're noticing this, you can always change it to integer. So yes, that's a good point. It is happening. So when the merge is happening, this does happen. Like, let's since both wait. Right. So this is kind of strange. It shouldn't happen. But I think this is because yeah. Actually, I don't know why this is happening. I'll have to see. So That is strange.
How about we
I'll
leave
get back
this
to you on that.
exercise for a moment?
Yeah. Sorry?
Let's leave this as an exercise for people
Yeah.
to figure out.
Sure. So this is just a small lab session, and once you set up the environment, you could try this out. Load the same 4 tables into this notebook, and select the Wimbledon winner of 2019. Then select all the rows where Rafael Nadal was like the winner or the runner-up, or even the second one would be Federer. And finally, just select all the rows where Nadal and Federer faced each other, right? So from these, you could do a merge and get this. So you could try this out, and yeah, come back for tomorrow.
All right, Kyle, thank you for this very, very informative and detailed session. Folks, I know that it's getting to be late here in California. It's 9:20 p.m. and in East Coast, it's past midnight. So thank you for joining us on our session. We look forward to seeing you tomorrow. Kyle has left some exercises, and please do do give it an attempt. Remember, you can reach out to our teaching staff on the Discord channel. They'll be very happy to help you with your questions. And I look forward to seeing you tomorrow. Any questions, any thoughts before I end streaming?